Hello everybody. Last lecture we have discussed about the basic Boolean algebra properties. What are they? If you revise, commutative property, associative property and distributive property. Commutative, associative and distributive property. Now we'll discuss the remaining part of your Boolean algebra. Let us see. The next one, which is very important, exam point of view also, consensus law. What is this consensus law? Let us see. Consensus law. What is consensus law? If you have an expression AB plus A bar C plus BC, it is equal to AB plus A bar C. I'll prove it. Okay. Right. Firstly, the first point you will be getting that doubt is, sir, how to identify this consensus law? Listen. To identify your consensus law, we have three conditions. The three conditions are: first one, we should have three variables, A, B and C. We should have three variables, A, B, C, X, Y, Z, anything, three variables. Every variable will come for two times. Here A comes how many times? 2. B comes how many times? 2. C comes how many times? 2. Every variable comes for two times. And one more important point is, only one variable in both normal and complementary form. What is that? Only one variable in both normal and complementary form. Okay? Only one variable in both normal and complementary form. So what is the conditions? We have three variables. In that three variables, every variable comes two times. A comes two times, B comes two times, C comes two times. Only one variable in both normal and complementary form. Only one variable in both normal and complementary form. Okay, side. Let me prove it. Take this expression. AB plus A bar C plus BC. Here multiply this BC with A plus A bar. Okay. A plus A bar is 1. 1 into anything is the same. So what is this? AB plus A bar C plus A into BC plus A bar into BC. Now in the first one and the third one, you can observe, what can I take common? AB can be taken common, 1 plus C will come out. In the second one and the last one, what can I take common? A bar C can be taken common, 1 plus B. 1 plus anything is 1. 1 plus anything is 1. What is my answer? AB plus A bar C. Proved or not? So AB plus A bar C plus BC is equal to AB plus A bar C. Let me take the same consensus law in a different way. A bar, B bar. Otherwise, one second. In place of B, suppose if you have B bar, my answer like this. What is the answer? Firstly, please check whether your condition is satisfied or not. What is the condition? Every variable comes two times. Three variables are present. Only one variable in normal and also complement. Sir, then B also in complement, sir. You may have the doubt. B is in complement, but B is not in normal form. C is in normal form, but not in complement. It can exist in any of the form, but only A is present in both the forms. Then what is the answer? Same proof you can try, you will get answer A bar C. Or you can indirectly say A bar comes na, product of these two comes here, you can neglect that product term. Similarly, if you have AB plus B bar C bar plus AC bar, now what is the answer? Here please observe, all conditions are satisfied. Here which variable is present in both normal and complementary form? B. B is appearing in both normal and complementary form. Okay, then the product of the remaining part A and C bar is present here or not? Yes or no? B is in normal and complementary form, A, C bar is present. Then what is the answer? You can say answer will be A, B plus B bar, C bar. Okay, is it clear? Examiner, to confuse you, you can give the first term here, second term here, anything is okay. Then how to identify, sir? The part which is having normal and complement. You see, B is normal and complement. These two we take. The remaining term we neglect. Product provided this is equal to product of these two. Please understand, I am repeating. Variable, its complement. Product of the remaining part here. This remaining part we can neglect. Is it clear? Variable, its complement, product of the remaining part is present here, you can neglect that remaining part. This is the easiest way to remember your consensus law. You can write this consensus law in a different way also. Examiner can give you like this also, A plus B into A bar plus C into B plus C equal to A plus B into A bar plus C. So these are another ways to represent your consensus law. Okay, first copy this, then I'll give you the point or a condition to remember your consensus law, and also we'll see few example problems on this. Please copy it. Right. Now, let us have a few examples to check whether consensus law is satisfied or not. Before that, please write down the points. To identify consensus law, three variables must present. Three variables must present. Three variables must present. Three variables must present. First point is three variables must present. Okay, second point. Each variable is coming for two times. Each variable is coming for two times. Third point, only one variable in normal and complementary form. Only one variable in normal and complementary form. Only one variable in normal and complementary form. Right. Or write down another way to identify. Or we should have a variable, and a complement. We should have a variable and complement, comma, and product of the remaining part. Then we can neglect the remaining part. Listen here. You have a variable, its complement, product of this remaining, you can neglect that remaining part. That is the meaning, right? And now let us see the problems based on this. Why should we use consensus lie? Is to eliminate unnecessary terms in the expression. One way to say is unnecessary term is given by a name, technically redundant terms or redundant gates in your expression. Write down the question. We have not discussed, please listen, we have not discussed logic gates yet. Just for continuity, take one problem based on gates, we can easily answer. Write on the point, question, example. Okay. Identify the redundant gate. Identify the redundant gate in the logic circuit shown in the figure. Identify the redundant gate in the logic circuit shown in the figure. Let us copy this. Right. This is the figure given. Okay. Based on which one is a redundant gate in this. Let me try to find it. From the given whatever we have discussed from the problems available, we can find it very easily. Listen. WXZ, W bar YZ, XYZ. Is there any consensus law here? Is there any consensus law? You may have the doubt, sir, W, X, Y, Z, 4 variables, how can we get the consensus law? You may have the doubt. See here. Please listen. If you observe, those conditions whatever I have given are sufficient but not necessary. Variables can be more than 3 also. Ultimately what you require is, please observe, you have a variable or not? its complement is available here or not? Product of this and this. What is xz into yz? Z into z is z only, xyz. Available here or not? It is like A, B, A bar, C. It is B into C. Then what is the answer? AB plus A bar C. So here W xz plus W bar yz. Or easily how to say, sir? Please listen. If you have a variable, its complement, product of the remaining terms is here. You can neglect that product term. We should take only variable and its complement. Yes or no? Here xz, here yz. Multiply xz with yz, xyz. Okay? Then you can neglect that. Okay? Is it clear? This what we discuss later. This is called AND gate. This is called AND gate, AND gate, and this is called OR gate. Okay? We'll discuss it very clearly later. Now you can see, if you take gate number 1, 2, 3, 4, what is the question? Which gate is redundant? Redundant means not required. So you can see in these 3 gates, which one is not required here? This gate can be neglected. Remaining 2 is sufficient to represent your function. So this is the redundant gate. Okay. So you can eliminate the first 2 gates. That is, third one is the, sorry, you can eliminate the third gate. You can keep the first 2 gates. That will also represent the same function. So gate 3 is the redundant gate here. Okay, copy it. Okay. Right. So based on this, let me do one more question here. Can I apply consensus law here? Please copy the equation. So in the exam, they don't give you exactly same AB plus A bar C plus BC. They can give a little twist like this. They can add more number of variables and all. Still, you should be able to identify. Okay, listen here. Here I can apply or not. Before directly giving the answer, let me take one proof. Let me try to get the proof. See here. X, Y, X bar Z, U, V, WYZ is my expression. Here also I have a variable, its complement, multiply with x plus x bar. Okay, multiply with x plus x bar. Then xy, x bar z, x into u, v, w, y, z, x bar into u, v, w, y, z. Is it okay? X plus x bar is 1. 1 into anything is same. So I am expanding by distributive property. Now in the first one and the third one, second one and the last one, take xy common. 1 plus, I can take xy common, 1 plus, take xy common, xy into 1, xy into what is this? U, v, w, z plus x bar z into 1 plus u, v, w, y. Yes or no? Right. Now, 1 plus anything, what is the answer? 1 plus anything is 1. So, xy, 1 plus anything is 1 plus x bar z, 1 plus anything is 1 again. So, what is the answer here? Xy plus x bar z. So, it is one way to expand your consensus law. Listen here. You have a variable, okay, you have a variable, its complement, product of these two is what? Remaining part is y and z is here. Yes or no? I have a variable and its complement, product of y, remaining part, that y and z is available. Extra whatever you have, it doesn't matter. Your answer will be neglect this term. Remaining two will be the answer. Is it clear what I am saying again? Variable, its complement, the product of these two is available. It is multiplied with anything, a, b, c, d, e, f, anything. It doesn't matter. My answer will be xy plus x bar z. Okay? Right. Now, please copy this. Okay, right. Now, let us see the next one. One of the application of this consensus law is, the next one is transposition law. Transposition law. Okay, transposition law. Listen. A plus B into A bar plus If you have a variable and its complement in this format, then answer will be product of the middle two and first and last. What is the answer for this? Transposition. According to transposition law, it is equal to AC plus A bar into B. I'll prove it. Expand this. A into A bar, A into C, B into A bar, B into C. You can see, can you take anything common here? A into A bar, A is 1, A bar is 0, A is 0, A bar is 1, or you can say X into X bar or A into A bar is always 0 plus AC plus A bar into B plus BC. What is this? Already we just now discussed consensus law. Variable and its complement, the remaining product. What is the answer? AC plus A bar B, which is same as this or not. Now I'll ask you one question. Tell me, what is the answer? I have a variable, its complement, okay, some product. What is the answer? Here also, can I take the middle two and first and last? Wrong, because examiner can interchange to confuse you. Never, don't multiply X and X bar. Here to get the answer, what is the procedure is, whenever you have a variable, its complement here, how to do the product? See here, variable into other than complement, complement into other than variable. They can interchange the position, doesn't matter. So what is the answer now? Variable into other than complement, X into Z plus X bar into Y. Okay, that is about your transposition law. Okay, that is about your transposition law. Please copy it. Okay, right. That is about your consensus law and transposition law. The next one, duality property. What is the next one? Duality property. Keep the heading duality property. Write down duality property. Write down. According to duality property, every logical expression remains valid, every logical expression remains valid, even though write down this, and interchanged with or in brackets, write down like this, and interchanged with or exchanged with or brackets, in brackets write down like this, and interchanged with or and write down 1 interchanged with 0, in brackets write down like this, and 1 interchanged with 0, 1 exchanged with 0, keeping the variables as it is. Continuation, keeping the variables as it is. I am repeating, please see. Any logical expression remains valid even though and interchanged with or, comma, 1 interchanged with 0, keeping the variables as it is. Next line. Make a note. It is used to convert a positive logic system. Into a negative logic system, and vice versa. Okay, right, let me prove it and I will explain. Suppose I have a function a plus 1. What is the answer for a plus 1? 1 plus anything is 1. You know it already. Right? Now, let us use one more thing. Keep the variable as it is. Replace plus with dot, 1 with 0. And here also 1 with 0 on both sides. My answer is, our expression is still valid or not? Tell me. A into 0, what is the answer? 0 only, right? Now, similarly, we know one more thing. A plus A bar B is equal to A plus A bar into A plus B. Okay, now apply duality property. Replace plus with dot. Here also A bar into B, na, take plus. Here A plus, take dot B. Correct or not? A into A bar 0. Yes or no? A into A bar is 0. A into B is AB. Yes, it is a valid expression. So, any expression, if you replace total expression on both sides, 1 with 0, 0 with 1, AND operation with OR operation, OR operation with AND operation, my expression will be still valid, or both sides it will be satisfying the expression. That is called as duality property. Okay, please wait. Don't write, first listen. Then how to find the dual of the function? Say function f of a, b, c equal to, say for example, take anything randomly, a bar b plus ab bar plus bc, some randomly taken. What is the dual of this function? Not expression, function I am saying. How to find the dual of the function? Take it. Here if you have dot, take plus. If you have plus, take dot. Plus, take dot. This is called dual. it is a D. Okay, for understanding, dual is represented with D. Take one more D. Let me apply dual to the dual again. What will be getting? A bar into B plus A into B plus B into C. It is the same as original function f of ABC. So you can see here f of ABC equal to A bar B plus AB bar plus BC. Take 2 times 12, again you will get the same function. So what is this condition? 2 times dual of any logical expression gives same expression. Okay, one important point. You may have the doubt, sir, you said some positive logic, negative logic system, it is applicable. I will prove that condition also, how it is applicable for what is positive, negative. We'll come back to that. First, understand the basic concept of duality. Okay, just copy up to this. Okay. Write down the point here. Write down 2 times dual of 2 times dual of any logical expression, 2 times dual of any logical expression, 2 times dual of any logical expression gives same expression. 2 times dual of any logical expression gives same expression. But there are some special expressions. Where one time dual. There are some special expressions where one time dual itself gives the same expression, which is called self dual expression. Okay, what is the self dual expression? There are, see here, if 2 times dual you apply to any function, you get same function. But there is some special case where one time dual itself gives you same expression again. One time dual is giving you same expression, then it is called self dual. I will give the example. take an example. F of ABC equal to AB plus BC plus CA. Take dual. A plus B into B plus C into C plus A. Now simplify. Here in these two terms, distributive property B is common na? B plus AC into C plus A. Now B into C. Okay, B into A. AC into C. AC into A. Is it clear what I am saying? AC into C. C into C is again C na? So AC. AC into A into A is again A. That's why AC. So AC plus AC is AC only. So what is the answer? BC plus BA plus AC, which is nothing but AB plus BC plus AC, which is same as your original expression. So here after dual also I am getting my expression back. This is called self-dual expression. Okay. So here if you want another example, you can check. F of ABC equal to A bar B bar. Here this symbol is bar, or you can take like this also. A bar C bar plus B bar C bar. This is also an example of self-dual expression. You can check it. You can try the proof and check it if you want. Okay. So first, what is the dual? You know. Okay, 2 times dual of any expression is same. Now what is the special case? 1 time dual is giving back again same expression. Then it is called self-dual expression. Okay. Copy it. You can copy it first. Once you have copied, I'll give you the condition for self-dual expression and what is positive logic, what is negative logic, that we'll discuss in the next lecture part. Okay. First copy this part first. Make a note. Note. With n variables, there are 2 power n minus 1. Please see here. There are 2 power n minus 1 self-dual expressions are possible. Self-dual expressions are possible. So if you have 3 variables A, B, C, how many self-dual expressions you can make? 2 power 3 minus 1. So n variables we can make 2 power n minus 1 self-dual expressions. Okay, is it clear? So I will give one homework. You can try in the next following lectures. Once we discuss SOP PYQs, I will prove it also, but take it as a homework. Prove that the number of self-dual expressions is, prove that the number of self-dual expressions is 2 power n minus 1 with n variables. Prove that the number of self-dual expressions is 2 power n minus 1 with n variables. Okay, you can try the proof. Anyway I will solve it in the class, but you try it first. Okay, take the logic, when will I get this condition, and try it. Okay, if you can try, it will be good. Otherwise we'll solve it again in the class. Okay, we'll continue in the next lecture. Thank you.